Hello, everyone. This is Jerry Tao. I'm a teaching assistant for the class fully employed MBA 201A Business Analytics in a summer session of UC Irvine. In this session, I'm going to make a bootcamp for Excel so that students can get started for this class. And before then, I'd like to make a self-introduction. I am a PhD student in transportation science. And I've been doing data analysis since 2010. So I actually started with my first data analytics project with Excel. And I was able to publish a paper by doing analysis with Excel. So Excel is quite powerful. And this paper is what I wrote using Excel. So for this class, business analytics, Excel is going to be the tool used for all the homework assignments and some exam questions.
Wait, you did this with Excel, Jerry?
Yeah.
Very impressive.
Okay. Let's see what we need to go through today. So first, let's go to the documents that I prepared for this session. Okay, all right. Here we go. So first, let's download some files. All right, these are the links to the files I used. Excel review for business analytics. Let's do so. Load. In this part, I'm going to demonstrate how to use Excel to make some basic operations, including formatting, and also how to use Excel formulas. This is the outline. If you're already very familiar with Excel, feel free to jump to the last part for a practice session. So you can check whether you can do all these techniques within Excel. Otherwise, follow me so that we can go through all the fundamentals in Excel so you can get started pretty fast for the 201 plus. Two parts we are going to review this time: basic formatting in Excel and also basic mathematical operations in Excel. In formatting, there's column and row width and screen manipulation. We can also hide and display rows and columns, and actually also sheets. We can also do copy and paste in different ways. And there's also autofilling provided in Excel, which is going to be very useful when you apply a formula to multiple rows or columns. And we can also do sorting and filtering to show certain rows in a specific order. And of course, we can also format cell display just like what we do in Microsoft Word. All right, let's get started with basic formatting in Excel. Here is a wine data. These are called sheets, and a collection of sheets in Excel would make an Excel workbook. Here we typically call each of the rows observations. So for example, here in this sheet, I counted from 2 to 100, and here shows a count at the bottom, 99 different observations. And different columns are usually also known as variables in data analysis. So here we have 7 variables as shown by the count number at the bottom. So for this data sheet, we can display it in different ways. A typical thing that you can start with is to lock the view for the top row, so that when you scroll down, you always see the variable names, so that you're clear everywhere what this column stands for. How to do so? Very easy. We just go to Excel View tab and find the freeze pane. Well, because I need to enable editing. All right, now I can do so. In View, if we go to freeze pane, we can select freeze top row. After this is selected, you will find that when you scroll down to the bottom rows, you still find the column names. That's actually the top row displayed. Sometimes we have observation or subject ID to the left. So for example, we can also do this freeze pane, so that Excel automatically divides the display into four parts, and it will use the top left corner of the cell you selected to divide the view, so that when you scroll down, you find that the rows above it still show, and when you scroll to right, you will find that the columns left to the selected cell will also stay. This will be helpful if you have multiple rows as variable names, and also multiple rows as the subject ID. For example, we can also move the active cell here and the freeze panes right here, so that we will find that the top 3 rows will keep displaying. And so as the left 2 columns will remain in display. This is how we can adjust which part the rows and columns show. We can of course also change the column width. By default, each column takes the same width. But when you want to show all the text within a column or cells, you can double click on the borders. For example, if you double click the right border of the column B, you will find that the B column will expand to the width, so that all the cell values are displayed. For example, this would be the widest row, so that this is how the column width adjusted. And because the points, it only takes 3 digits. So if we double click the column border to the right, it will adjust to a very narrow row. You could do the same to each different columns to change the column width. Just like what you can do to row width. If you want to change the row width, you can do so by scroll them up and down. All right, this is how we can adjust column and row width and split screen by freezing panes or rows. We can also hide and unhide certain rows and columns. For example, if we select these rows and right-click, we will find a button saying hide. So once you do so, you find that the row index changes so that you find 1, 2, 3, and it jumps to 10. This happens because the rows 4 to 9 are hidden by our previous operation. And we will see a trace left that here you find a double line. We can also hide certain columns in a very similar way. Select a few columns by dragging from the column index and right click, you can also hide. These hiding operations are useful when you have some interim calculation that you don't want the final product or sheet to display. And you can actually hide a certain sheet altogether. For example, if I click hide, then the sheet wine data disappeared. We can, of course, have it back by clicking unhide. And we find that there's only one sheet that was hidden, and we can have it display again. And if you regret what you just did, you can, of course, unhide all these rows by clicking unhide, and also all the columns. And if you ever doubt when you received a new Excel workbook, whether there's any hidden rows or columns, you just couldn't discover immediately, you can simply select all by using Control and All. Then you can click anywhere, then you can click unhide, so that you find all the rows and the columns display without being hidden. All right, first 3 steps covered. Next is copy and paste, and especially paste special. So let's do it here. If we copy a column, different information can be retrieved, either the values and or the formulae associated with it. So if we want to copy and paste the values directly, then simply select some rows or columns or some areas you want to copy, and you can use Control+C to copy it. Then find the destination you want to save the information. For example, if I choose here, then this will be the top left cell for the destination. And there are different options for pasting. For example, this is to paste by automatically determining what the program believes you want to paste. Or you can choose values only. Or if it contains any formula, you can choose formula. And of course, you can transpose it or get some formatting, or only paste the formatting of the cells without pasting any content, either values or formula from the cells. And you can also paste the link. So this time I'm going to use paste values only, so that you can find that the outcome is exactly the same as the origin. I will introduce additional paste special options we can use later when we apply formulas in Excel. There is also auto-filling. So I think this is useful when you want to add an ID row. So for example, we like to insert an ID row so that we can index these different observations. First, we can insert a column by selecting a whole column and click Insert in the Home ribbon. Then we find that it inserts a new column to the left. So here we can name it as ID. And if we insert the first few index, Excel will automatically understand the pattern and autofill the rest. How to autofill all the rest? This is done by selecting first some prompt cells that we type in by 1, 2, 3. Of course, this means we should see it go further as an increasing integer. So we would move our mouse to the bottom right corner and use this little square button to autofill. If you double click it, it autofill to the last row that's consistent, that's next to it. Otherwise, you could also do so by dragging and find the destination that the stopping point that satisfies you. For example, you can increase it to fill more index or decrease it so that it doesn't fill all the rows. So this is how we can apply autofill. This also works when we have formulas in the cell. So it works more than just the index or integer IDs. So we have completed 5 operations in the basic formatting. The 6th one is sorting and filtering. This will be interesting if we do this to price. So what if we want to display this sheet from the smallest, the lowest price to the highest? This can be done by first selecting the column price by left-clicking this column H when the cursor is displayed as an arrow. And next, we would go to sort and filter in the home ribbon editing panel. So we can do first sort. This is easily done if we do sort smallest to largest. And when you do so, it will prompt to a warning saying that Excel detects the data that has multiple columns. So there's additional information beside this specific column, but we didn't select them. So what do we want to do? We should expand the selection so that all the rows will be also sorted, not just price column. As you can see, this price is now sorted from 0 to the highest, which is blank. This blank is sometimes considered to be highest, sometimes considered to be smallest. So you should pay attention to the cells with missing values. And as you can see that other rows are also sorted by price. This is proven as if we go to the ID row. Recall that we just created this ID from the first observation to the last, but after the sorting, this ID remains in a relative position. So that originally the first row was this Australia with 350 as the price, but now because of the sorting, this row is moved down to here. And we can also apply more complex sorting by using custom sort. So first we need to expand the selection, and automatically Excel determines the selection as this area. However, we can specify it. For example, we ignore ID. So the ID column will not be changed, but we can sort the other rows and columns. So if we go to custom sort, we can sort by one and more variable names. So we can sort by price, smallest to largest, just as what we did. But we can also add more rules. So for example, if we meet observations with the same price, then we can also further sort it by, for example, I would go with country. So because country is a text column, this cell value will be ordered from A to Z or Z to A. But you can also create your own custom list. So you can go through these further later. After this, we find that the ID column remains the same as before. So this actually breaks the first association we created. Further, this is a demonstration. But if we go here, we find that the country names are also properly sorted. If we go to the price of 75, all these are US. Okay, so this is how you can sort a sheet by one or multiple columns. Of course, we can also do filtering, just as what we did for sorting. The filtering is usually done through the variable names, and it adds a drop-down menu to the right of each variable name. For example, if we go to country, we can select if we want to display only US information, then we deselect the select all button, but select US instead, so that the remaining countries are all US. And we can resume what was there, and we can go here to price. So for a numeric column, all the unique values of the in the column is displayed in filtering. If you want to remove missing observations, you can deselect this blank, and you will find that the last row that was here is now gone. And this is how we can do filtering and sorting. If we want to remove filtering by showing all rows, then simply you can do this by clicking this clear filter from price. Great. Now we've done most of basic formatting except for the last one, that we can do the font formatting. So one very useful tool for me is this format painter, notice that this ID variable name has a different font and size and color with the by a consistent format. We can use this format painter. So if we click it once, then from the origin of the formatting to the destination, then we see immediately that this ID now has the same formatting as the other variable names. There are other type of formatting that's useful. For example, if we want to highlight the cells with missing value, we can do this bad or maybe warning text. So you can apply the formatting in the style panel under the home ribbon. And we can also do conditional formatting. For example, if we want to have different formatting for the cells of missing value in this destination column, then we can go to format, well, maybe conditional formatting. So we want to highlight cells and equal to, because the missing value is simply a string with 0 character inside. So we can use double quotes around nothing to represent it. And for these type of cells that have missing values, we can use light red fill with dark red text. We can also apply custom formatting, where you can define the font, border, and fill for the cells you want to highlight. And this time we just go with this red fill. Okay, I guess I should probably apply a formula instead. Let me try it again. Oh, yes. So this time it works. The difference between using equal sign or not will be demonstrated very soon, where we go to basic Excel formatting. So that after this basic formatting, let's go to basic mathematical operations in Excel. In this part, I'm going to demonstrate how to use cell address, specifically relative and absolute cell address or reference, and then equation that begins with an equal sign always. Then we're going to see some basic mathematical operations, including addition, subtraction, multiplication, division, and power, and so on. Then we can build our own formula. For example, percent change, and display some formula in worksheets. And also use some basic Excel functions, such as mean to find the minimum value, such as the functions to identify the minimum, maximum, the summation, the average, the count, and count under some conditions. After that, we're going to use formula for more operations. Then we can also build a pivot table. We're also going to see some common Excel errors so that we can understand what might go wrong if we see these error symbols. So let's start with the basic. Here is a sheet that's based on 2 cells. Number 1 is 9 and number 2 is 4. So that with proper reference, we can find the summation of number 1 to number 2. This is done by first typing in an equal sign, then followed by some cell reference. B here represents the column B, and 1 is the row index, row 1. So here it means column B and row 1, which is 9. Plus sign just means summation, and B2. So we declare that this cell returns the result as B1, as the content in B1 plus content in B2. And of course, we will have 13 as the result. With a very similar method, we can do subtraction. Subtraction is done in a very similar way. Remember that we need to type in this equal sign to make it a formula. So a common error is, of course, missing equal sign. Let's see what happens if we did not type in equal sign. So if we simply type in B1 plus B2, it returns a static text. Even if we have a equal sign afterward, then it won't give us what we wanted. So this is incorrect. Remember to include the equal sign in the beginning of the cell if you want to use cell reference. Similarly, we can do number 1 times number 2. This is by the star symbol. And well, I guess here I meant division. Simply give it a slash as the formula shows. We can, of course, do a square. The power operation is done by using this symbol, and which is shift plus 6. So this is B1 raised to the power of 2. With square, we also want to know how to do square root. This is done by using a formula. So this formula is represented by the function name, which is square root. And when you type in, for example, if I clear it, when you type in the function name, Excel pops up some function names that matches what you already type in. So you can double click it to use it, and click the cell that you want to use as reference, and close the parenthesis so that this will be a complete function. That's how you can get 3. Since square root is simply a number raised to the power of a half, so we can also derive the same result by using power instead of the square root function. And of course, we can apply a similar function to arrive at the cubic root. So for example, the cubic root for number 1, which is 9 here, is about 2.08. And this is done by using B1 raised to the power of 1/3. And notice here, I had to use a parenthesis around 1/3. This is opposite to a common error. If we miss the parenthesis in the formula, the arithmetic priority, where power is taken a higher priority over product, it's going to give us a wrong result. For example, here, as I illustrated with a formula where the 1/3 is 1/3, it's not protected by the parentheses, then we get a very different result, which is 3. This is actually B1 raised by 1, which equals 9, right? Divided by 3. So always make a note which operation takes first. And the priority gives to power over product, which is over summation. We will see a similar rule applied here when we want to find the square of difference. If we want to find the square of the difference between number 1 and number 2, and because of the arithmetic priority of power over summation, we need to protect the difference between B2 and B1 using parentheses, then followed by raising it by a power of 2. So this is how you can find the difference, which is 5 raised by the power of 2, and that's how we can get 25. Similarly, we can also do summation of squares, and because of the arithmetic priority of power over summation, we do not have to use parentheses to protect B1 or B2, because the summation will be done after these power operations are done. So keep in mind of the arithmetic priorities. Speaking of the relative change from number 1 and number 2, this is where I see some students in the beginning forget to use the parentheses, so that the results were incorrect. To find the relative change from number 1 to number 2, we first find the chain, right? Which is B2 minus B1. We typically use the newer or the latest observation minus the older. So assuming that number 2 came after number 1, we use the difference, then divided by the original value, which is the older observation. Here, it'll be B1. And because 4 is smaller than 9, we find this number to be negative. As I illustrated here, if we miss the parentheses in the formula and derive at this formula, then we will have a wrong result. Here, B1 over B1 is calculated first, then the result is subtracted from B2. So this is just as if B2 minus 1. So 4 minus 1 will equal to 3. This is why we have 3 here, but this is a wrong result. Some useful functions for financial and economic studies is exponential and logarithm. So the natural exponent of number 1 can be calculated this way. EXP, where you can learn, if you want to learn more about these functions, once you select them, and you can left click here, then the help panel will show up. Then it tells you details about each function. For example, this will let you know that this exponential function returns e raised to the power of number. You can also find the natural logarithm of above So if we already raise a number by then to its natural exponent, the logarithm of this natural exponent is the number itself. So if we take the natural logarithm, a function named ln, and the cell value is this one. So we find that this equals exactly number 1. We can derive at the same result by using a different function. That's the logarithm. Here, the default base would be 10, but we can change the space by using the natural exponent of 1 to find the same result as above. So here we go. That's how we can do basic mathematical operations in Excel. I totally understand that in the beginning of using any statistical tools or software, it's very not uncommon to run into errors. So let's get familiar with some common error symbols. Here I have certain raw values. Some are numeric, some are text. So we could see different type of errors. This division by 0 can be found if we divide a number, A2, which is 100 here, by A1, which is 0. If we divide any number by 0, this the result is undefined. That's why we see this error, which is division by 0. Sometimes we see this value error, and we can understand the error or a description of this error by left click at this error sign. Here it shows that this means error in value. Let's examine. This is because in the formula after the equal sign, I attempted to make a summation from a numeric value, which is 100, with a text or a string. Of course, we cannot possibly add a number to a text, so that's why we have this value error. A third type is the reference. Here, this is invalid cell reference error. This sometimes happens when we remove a cell that's further used in other cells, because the cell being referred is missing or removed, so that we can see this type of errors. Sometimes the operation result is undefined, just like division by 0. If we try to take a square root of a negative number, then we can result in this number error. Similarly, if we type the formula or the function name wrong, we can have this name error. This is because I intended to make a summation of these two numbers, but instead of sum, I mistakenly typed in SU without the M to finish the function name. That's why we got this name error. So don't worry if we ever run into the errors, as long as we rectify, or sometimes we leave it alone, it's fine, as long as we understand what causes such errors. Well, good that now we have already learned how to do basic mathematical operations and avoid certain common errors. Now we can apply for the skills in Excel by using basic Excel functions that applies to a larger number of observations or cell values. Here, I have two columns of numeric values. And we can find the sum, the max, the minimum, the average, and count values of based on these two columns. For example, I just use the first column to make an illustration. If we want to find the sum of all the numbers from B7 to B106, we simply type in these function. Then we can actually also, if you hate to type the numbers, you can drag and select B7 to B106 and finish. As you can see, we arrive at the same value as before. Of course, we can also find the maximum value, which happens to be 100, and whereas the minimum is 2. If we use this formula bar by clicking inside, we can also easily find the referred areas or rows or columns of a function, so that we can know what areas or what values determine or affect this result. And from here, we understand that this highlight area, which is from B7 to B106, has something to do with the final result of the B3. We can also find the average, which is the mean value. And we can also count numbers that's greater than 100. That's actually equal to 100. This is done by using count if. Count if is where you need to supply two arguments. The first is the range. Here is B7 to B106, and find a criteria. So here we want to find the number of the observations that has exactly 100 in it. So using this, we found that the result was 3. How about if we want to count the number of observations that's less than 100? This is done by changing the criteria argument slightly by using smaller than 100 protected by the by double quotes, so that we know that there are 97 different rows actually, or observations with a value smaller than 100 inside. All right. These basic functions is commonly used in statistical analysis, especially average and count. So this will be helpful, and you can of course use the second rule to derive your own results for a different set of values. With this understood, let's find some interesting small practice. Here is two panels of the stock value observations. We have the stock price from the first day of 2020 to the 10th day in January 2020. And similarly, this is a different stock. So I'm going to make the demonstration from the first stock, and you can practice using the second stock using a very similar technique. But this will also be shown where the use of relative and absolute reference cell is relevant. So first, how can we find the growth since previous day? So this growth here is understood as a difference. So we can only determine the growth if we start from the second day, because there's no value to refer before the first day. So that growth is only defined in the second day and afterward. As I demonstrated earlier, here we need to apply a formula to calculate the growth. So that's why we need to begin with an equal sign to start a formula. And because we want to find the difference, and this difference is always the latest observation, which happens to be C2 minus the previous observation, which is B2. And here we didn't have to use the parentheses, but it's okay if we leave them here. And if we drag this formula to the right of it, as I showed earlier how to do the autofill, we find that the values keep changing, and each of them, as we look into the formula bar, is defined as the cell value above it minus the cell value left to the previous one. And this is desired as for January 3rd, this value should be the price on the 3rd minus the price on the 2nd, which is 1 here. And if we observe what happens here is filled as K2 minus J2. So it's still the result that we wanted. Now let's go to the next row, where we need to find the growth since the beginning of the year. Here, the beginning of the year is, of course, the first day in January. So every cell needs to, each day needs to find the difference of its current value from the January 1st value. Here, how can we do that more automatically? We still begin the formula with equal sign. And here we need to use some absolute reference. First, we still need to find the current value, which is C2, right? And we can also follow it by minus sign. However, for B2, we would put a $sign in front of B to make B absolute reference, so it does not change when we autofill the formula to other cells. For example, if we autofill it to the result for January 3rd, we find that this value is very different from what we see for growth since previous day. This is because we used an absolute reference for column B. Here, this column index B is an absolute reference, so that it did not change when we move the formula from C to D. And of course, we can autofill this and examine whether the formula does what we want it to do. Here, this last observation for January 10th, 2020 is defined as K2, which is the price, stock price on the 10th in January, minus B2, which is the first day. And this is exactly what we wanted. So that here you can find the difference between relative reference and absolute reference. Without the without the dollar sign, the cell index is a relative reference, so that when you autofill or copy and paste the cell to other cells, you will find that the index reference keeps changing. D2 minus D2 to D2 minus C2 to E2 minus D2. It keeps rolling. But if we lock certain columns or rows, actually, which can be also done, we can lock the reference to make it an absolute reference, so that B2, so that this column B does not move. We can more specifically use an absolute reference to the row value as well, but here we won't find much difference because as we here, I just designated B2 together as a reference, as absolute reference for both column and row index. We could actually do so by selecting B2 and use F4 button on keyboard, so that the cell together for both row and column index will be protected by the dollar sign to make it absolute reference. Because the row number did not change, so that when we apply this absolute reference, the absolute reference of the row index did not make a difference, but it will make a difference if we apply the formula to different rows. Here, let's calculate the percent growth since previous day. So to find the percent growth, we need to calculate the relative change, right? So for that, we first find the change, which is C2 minus B2, and this is the difference. Then we need to divide it by the by a reference number, which would be the older observation. And remember earlier we learned that we must protect this by parentheses. This is because of the arithmetic priority of division over subtraction. So that we would click cell B2 again. So this gives us a ratio. As we can see, this is 0.1, which is 10 over 100. And to make it a percentage, we can use this formatting tool to show numbers as a percent. Then we can apply the same formula to the rest of the cells. And to make sure that gives results that we wanted, check some cell. And here we find the last cell to be the difference between K2 from J2, 1 day increase divided by the last day price. So this is what we wanted, so we know it's correct. And of course, we can do a similar thing to calculate percentage growth from the beginning of the year. So here we can calculate the difference of the C2 from B2, then divided by B2. And because this growth needs to be relative to the beginning of the year, so we need to make B2 the first day stock price, our to make it absolute reference. Okay, so here we go. We can also change that to percentage. As you can see, the result is very different from the percentage growth since previous day and since beginning of the year, because we used absolute reference for the relative and absolute reference is very important when you copy the cell values or cell formulas. So here, if we want to use the same formula for a different set of stock price, and if we copy this growth since previous day to the second stock, which is a few rows below, let's see what happens. Here, because earlier we did not use the dollar signs, so this is a relative reference. So here, when we copy and paste cell C3 to C10, we find that the row number also changed, so that this gives us the difference between CD9 and the B9. And this is as desired, so we can keep it here. Here, if we did not use, here, if we keep this absolute reference of the B2 and paste cell C4 to C11. Let's see what happens. Let me do it again. To make sure, we just examine the formula bar of this cell. We find that this gives us the difference between C9 and B2. This, of course, does not make sense if we compare different stock between different days. This is because we used absolute reference in a cell where we copied from. So if we remove the relative, if we remove the absolute reference of the row number, but keep the absolute reference of the column index, then copy and paste cell C4 to C11 again, we find that, well, I did not remove it, that's right. Okay. Copy and paste again, we find that the difference is gone, so that this result in C11 is what we wanted, the difference between C9 and the B9. So keep practicing of the use of dollar sign to designate either column or row or both of them as absolute reference, and understand which one should apply and at what condition. And because of this, we can also apply the same formula by copy and paste it to a different stock. Then we can also examine whether that's what we wanted. So if you want to change the number of digits to display, you can use number and decrease or increase decimal. So if we increase decimal, we find that this is not exactly 0%. Notice that this percentage is only to display. Inside it, it only keeps the formula, and the value will be actually a ratio or fraction. So for the computer, for example, the 17% is not understood the same as a number 17, but it'll be equal to this value, which may not be exactly 17%. So that's the distinction between a display and a formula or the value it contains. If we copy and paste this, of course, we will run into another error because previously we used absolute reference for both the column and the cell, for both column and row index. So here, if we want to find the correct answer, we should, of course, change the absolute reference. Here, we should use not B2, but B9, right? And this would be also B9. And to make the autofill easy, we should designate column B as the absolute reference, because when we move or autofill this cell value, the formula to other days for the second stock, we want to keep the beginning of the year day, which is January 1st. The position would stay in column B. So we can examine it by going into one of the cell to see whether it tells us the result that we asked for. Here we are finding the difference between K9 and B9, which is the stock price difference between 10th and the first day in January 2020, divided by the first day stock price. This is exactly as we wanted. All right, so that's some practice of relative and absolute cell reference. And lastly, I'm going to show the pivot table function in Excel, which provides some summary statistics of a worksheet. So here, let's start from the beginning. Okay. Let's say that we want to count the price, and if we want to find, for example, the average price and the number of wineries by country, we can use a pivot table. By first selecting the whole sheet, then we go to Insert Pivot Table from Table and Range. And here we already select the table or range. Otherwise, you can start from the beginning by selecting the range of it, which here shows the wine data sheet, which is symbolized by the exclamation mark, followed by the absolute cell reference from A1 to H100. Then we choose where you want the pivot table to be placed. Here, I'm going to use place it in an existing worksheet and find the location here. For example, we want to place the pivot table here. Then you just click OK. Oh, well, unfortunately, I won't be able to make it because it overlaps with another. Let's move it to a different location then. All right. Select the sheet range first, then find the location. Okay. So here we have a pivot table, which is a template at this moment because we have not tell Excel which to use as grouping and which to calculate statistics. Remember that we wanted to find the average price of and the count of wineries by country, right? So that means we want to use country as a grouping variable. And here I would place it for rows, but of course you can also make it into columns. So basically what I do is that I drag country, the column, the variable name or the first row in this in column B, that's the column name. So I drag country as rows. As you can see, this template already changes. And we want to find the price, right, as average. So we would place it into values. Here, automatically, it thought that we wanted the sum of price, but we can change this by clicking this button, value field setting, and change from sum to average so that we can find the custom name is average of price. Of course, you can change it to, for example, mean price. Okay, because it's very mean. Now you can see that it gives a summary statistic of the average price of Australia, average price of France, and here average of the US, plus the average of all different observations. We can add another column to find the count of different wineries by dragging winery to value again, and automatically it gives us count because winery is a text variable, so we won't be able to find the sum or average or min or max of this column. But count makes sense. So that from here, we know that Australia has 7 different wineries recorded in our data sheet, and the mean price is 470. So this is how we can make a pivot table by going to, by selecting an area of the sheet, then go to insert pivot table and drag the column names or variable names into appropriate sections. After this, we can also use filtering. For example, if we click row labels, we can, for example, remove US. So it only shows us all the and Australia, so that only shows us the European country statistic. And we find that the rows is 2 rows less, but the grand total stays relative to the rows selected. A pivot table is also quite useful when we want to create a frequency table and make a frequency histogram. Here, for example, if we want to make a histogram of the price, that's where using Google search is quite useful. I followed the instruction here, how to find the frequency distribution in Excel. And it told me that I create pivot table, then find the value field settings and find the grouping variables here to make these different groups. So that for the operations that we are not familiar with, my tip is that Google a lot. So for example, here, if we want to use Excel to do frequency table using pivot table, we can find many different tutorial that show us step by step how to do so. So feel free to check these tutorials yourself. Well, for me, I'm going to start from the beginning. Let's first select this column. of the price and insert a pivot table. I will use place the pivot table in the same cell, in the same sheet. Here it pops up a template. We simply need to move price to values. And also price to rows. So here it automatically gives us the a frequency table. The rows is defined by the grouping. So if we select any of the row label and right click it and go to group, then we can define these groups. So here this group is defined by 0 to 1900, each increase by 100. If we want to make make the beans smaller, we can go by 200 each bean, so that as you can see, each row represents a range of 200, and the associated count of price will increase. If we compare with this one, oh, these two are somehow linked. That's good. So that we know that there are 98 different observations. And to make a chart out of it, you can go to pivot table analysis and pivot chart. As you can see, it automatically gives some recommended chart, and we can go by this default. And we can drag and place the chart somewhere else. And we can also change the elements we want to show in any Excel chart. By selecting the chart, then go to Format and Design. So the chart design has different elements. For example, we can go to Design ribbon and add chart element, and we can either add or remove the grid lines. Here, the grid lines are removed, but we can have it back. We can, of course, remove or add the legend, because here the legend would not give us any additional information, so we can remove it. Then we find that this chart title does not give a descriptive meaning, so that we can change it by selecting it to frequency distribution of the wine price. So that means, for example, here there are about 44 different wineries that produce wine with a price between $0 and $199. So here, because all the wine has, we can remove the blank by deselecting it, so that you can also find the corresponding frequency distribution chart, or the histogram is also short of the blank column. And for a frequency distribution chart, normally we want those bars to connect with each other. This can be done by using different designs. For example, here, we can go to this one, quick layout. And this layout 8 gives us a chart with 0 spacing between the bars, so that we can understand easily that the range of values are connected to each other. And here we can also change the column and the axis titles. So the access title can be also added here. We can remove or add the access title. So for example, if we already know this is frequency distribution of the wine price, so we could possibly remove the access title on the horizontal axis. But we can have it back. For example, if we want to stress that this is in dollar, and we can also change this as count of the winery. So that we make these very explicit. However, it might be more correct to. Oh, I see. Winery is actually fine. I was curious whether there's any repeated winery here. There actually is a few, so that how can we find the different types? I see. There are some repeated observation, possibly. So this is how we can make any pivot tables and associated charts for a pivot table. For any charts, you can actually make for any tables, you can actually make a chart by using this insert and recommended chart. So you can go through different charts. We can apply a line chart or pie chart, bar chart, area chart, scatter plot, or map. There's also tools for specifically stock, surface, and radar, and so on. But the most commonly used one would be column, line. And I rarely see pie charts used, but bar charts are more common because people are more sensitive to length instead of area. So even for ratio, it might be more efficient to illustrate using a bar chart instead of a pie chart. Well, this would be a conclusion of my Excel review. I used almost 90 minutes. The last part is for the students to go to the self-practice part, where you can make a demonstration for yourself, whether you already understand all the content and the procedures of basic formatting and basic mathematical operations in Excel that we have gone through. However, I decided to add an R demonstration just so that you can know that there are tools available beyond Excel that you can use to do data analysis and visualization. This is totally, the R demonstration is totally beyond the scope of the course. It's not required for any part of the course, either homework assignment or the exams. So feel free to ignore it or skip it, but can be useful if you move on later to a more larger scope of data analytics project. Here, I would simply follow with this car data exercise, but I would move to my tool, RStudio, for illustrating how data analysis can be done very easily by writing simple script. So in the files that I shared, which is here, right, you can find an R practice for business analytics. You can download it. And this is an R script file. Which can be opened with a notepad when you have not installed any tools for R. For example, you can open this with Notepad. Because here I included, all right. Let me update these files. So with the updated file, you will find that there's download link that we can use to have the R tools installed. So here, if we open it with the Notepad, we simply find it to be a text file of only a few rows. So here I included the download link here. So we can copy and paste it, which just happens to be this one. Yeah, so we can install R, and then we can install R Studio Desktop. R is simply a scripting or statistical analysis software, whereas R Studio is what's known as IDE, an integrated development environment that just makes things look better. For example, this is the R Studio layout once you install them. So if you download R, then download R Studio, then install them, then you find a similar layout as what I have. So from here, we can open the R script that I just downloaded. You simply drag it to this script editor. Let's open it. So that let's go to this R file. So if you open the R file inside of R Studio, we will see that it's a text file with different coloring. All these make it larger. Okay. All right. All these green colored text is commentary. So any text that's followed by a pound sign is commentary. That means the programming or statistical analysis tool would recognize these as comments. It won't yield any results or call for any functions. So I use this to insert some useful links, for example, where to download R in R Studio. And there's also some online textbook we can use to do the analysis. So here I'm going to show you how the practice in Excel for the card data can be done in R just as easily, if not easier. So here on the last worksheet in Excel, we have this card data. We have a column named the rank, manufacturer of the car, and also model, and also sales in February 2019 and sales in February 2018. And our exercise includes these 8 steps. We can show the data, then filter the table to show only total data. Then we can find average and the standard deviation for the mean and the standard deviation value, and create another column to assess the difference, actually percent difference from 2018 and 2019. Then well, this formula and the computed values, and also add a conditional formatting rule of your choice to the new column, and also create a pivot table. So all these, or most of them, can be done in R easily, and it'll be useful when you need to create similar reports for numerous different Excel files. So with Excel, this can be easily done for one worksheet, but when you need to repeat the same series of analyses for many different sheets, for example, when you receive this sales report from multiple dealers that you manage, then creating the analysis in Excel would be very tedious. You can possibly automate part of it by using Excel macro, which is also an Excel scripting tool to automate the procedures. But that part is not very easy to handle for myself. Whereas I find that using some scripting language, such as R, makes the procedure very pleasant. So let's show how we can do this series of cumulative exercise with car data in R. First, we need to install some packages. Upon installing these tools, only the basic packages are installed, but for data manipulation and plotting, we need to install additional packages. This is done by using install packages function. A function in R is starts with some function name followed by parentheses. And here we are announcing that we need to install package named tidyverse. So if we in RStudio, if we use keyboard, the Control plus Enter, we can execute one line. So you can install that on your computer. This should do easily. Well, I won't. Then, after installing the package, we need to load it to our current session. This is done by a function called library. So we library the package named the tidyverse we just installed. And using this function by typing Control plus Enter to execute it, we can list all the packages installed in tidyverse. So there are about 30 different packages installed. So once we have the tools ready, first we need to specify our working directory. This is basically to tell the computer where to find the files. that's necessary for this analysis, and as well as where to save files once we generate any. So this is done by using a function called the set working directory. And I set this work directory to the folder where I have my files downloaded. So I have these two files here, but to reproduce what you may see, typically you probably so you probably have your download folder and with these files downloaded. So you can copy and paste this folder address here. Well. Okay, now this works. And note that the eliminator of different folders is by the forward slash. So you can do C users and download. So this is gives the computer the file path of the downloaded files. All right, then Control Enter. So now the computer understands that this is where it can find all the downloaded files, followed by importing the data. We import the data by using another package called read Excel file, simply by using library, this read Excel file. Then we read this Excel file by using read Excel function, giving it a path to the name of the Excel file, and specify the sheet name, which is card data here, and give it a range. So here in the Excel sheet, we find that only this part contains the data. Although here there's also information, but this is the instruction, right? So we want to make sure that when importing, only this part goes into the red file. So that's why we need to specify the range from A1 to A1 to E21. That's because we have 5 columns and 20 different observations. And this sign, smaller than, and followed by a minus sign, which is actually a left arrow, is the assign symbol. This means when we read the Excel file, we assign the outcome, which is an object, as card data. And once we do that, okay, we find card data to be included in our environment. To reproduce what you may have from the beginning, where you do not have any variables or data loaded, then we can do this. Let me reproduce so that you can find all the different procedure outcome easily. Here now I restarted our studio, and it comes with a clean environment. So I do not have any variables included. We would repeat the different parts that we already did, so we can find what they mean. So install the package. As you can see here, that's the console that shows the functions being illustrated, being executed. And all these orange colored are messages, some are warnings. And here it shows that package is successfully installed. Then we can load the package. And it tells us that these packages are attached. Then we still set our working directory. And we can read the Excel file. If we do not use the assign function, but only read the Excel, we find that we need to library load another package called the read Excel. Without the assign function, the data is only read to the memory. It does not save into a designated object. So that's why we use this left arrow to save the result of a function into an object. If you want to know more about how this read Excel function works, you can use a question mark followed by the function name so that it gives you help information for the for any function. Here it tells that this read Excel function is from the read Excel package, and the use of it is to read Excels and Excel sheets. It tells you what arguments can be supplied here. Here I only used path, sheet, and range, but you can also specify the column names, the column types, what will be recognized as the missing value, and whether we need to trim any observations of the first rows or skip any rows from the beginning, or do we need to read a maximum number of rows and ignore the rest. So that's how we can get the help document in an R function by using this question mark and using Control and Enter to execute this seeking for help function. Well, let's go to the data manipulation to show how the exercise can be done in a different tool. So here we can view the hard data, which is an data frame object formed by reading the Excel file. It shows exactly the same information as what we have here, right? Except that it does not have any formatting in it. Then we can also find the column names of the data frame. And when you execute it, the result prints here in the console. And here we know that there are 5 names. The first is rank, and the last is sales in 2018. We can also find the structure of the data frame. And the result is like this. It's the column name and the type of the data, which is a numeric or rank, and the character for manufacturer. And there are 20 rows in each variable. And there are the first 4 observations of each variable. So from here, we know the type of different variable, whether it's character or numeric. You can also find some summary statistic of each variable by using summary function, followed by the parenthesis and the argument would be the car data object. Summarizing the car data frame is the rank, which gives us the mean to maximum, as well as the quartiles and median and mean values. This is the same for any numeric variables. For example, in sales, we find the same summary statistic. For the two character variables, manufacturer and model, it only gives us the length and class and mode of the variable. So now it's interesting to see what are the unique manufacturers. This can be done by using the unique function and followed by a specific variable to extract or specify a variable inside of a data frame. We use this $sign. Now this is very different from Excel. This $sign means that from the car data frame, we find a column named manufacturer, and using Control plus Enter, we execute this specific line of the script, which returns the unique manufacturers of the inside of the car data sheet. There are 9, 10, 11 different manufacturers. If we want to make a frequency table, this can be done by the crosstabs function. The result is like this. Here, Kia has 3 different observations in the table. We can also check whether that's true. So Kia, and Kia. Yeah, that's why it gives us 3. That means there are 3 rows with Kia as the manufacturer. This is done by supplying a formula. Manufacturer means that it will be used as a grouping variable, and the data is car data. So we can simply expand all the columns and find all the summary statistics by giving these lines of scripts. The second practice, to filter the table and show only rows where the manufacturer is Toyota, can be simply done using this pipeline function. Here, we start with the car data frame and using this percentage sign, followed by greater than sign, and followed again by percentage sign. This is understood as the pipeline operator or pipe operator. Next step, using this car data, we filter the manufacturer. Well, let's just see the result. So as you can see here, there are only 2 observations where the manufacturer is Toyota. And we find that for the Corolla or Camry, yes, the sales is this much for 2019, and this is for 2018. The longer text for the variable names and values for text string is truncated, but you can still see the total result by using this view function. So if you do this, it pops up a variable viewer, so you can see the result in the viewer being in a window instead of in this console as plain text. Well, the same operation can be done using a more traditional way, but as you can see, this looks more complicated, but it gives us the same result. This is still the same 2 observations for Toyota. This is simply designating that within car data, we find the rows where the manufacturer is equal to Toyota. For the equal, we need to use double equal sign to make it a logical test. So that if this is true, it gives true, and if it's false, it's the manufacturer where the manufacturer is not Toyota, it returns a false value. So as you can see, we can simply use 2 lines of script to filter the table and find where the manufacturer is Toyota. We can apply the same pipeline operator for the mean and sample standard deviation of the sales data. So this can be done using the summarize function. So here, starting from the car data frame, we summarize by creating new variables. Average 2019 is the mean value of the variable sales in February 2019. Because this sales February 2019 column has some special characters, which is parenthesis here and space here. We need to use this backticks to protect the variable names. And we can also create another column of a standard deviation. Well, without reviewing too much, let's just see the result. If we use Control and Enter to execute these few lines, we find that it gives us a small table, average 2019, that's the average sales in 2019. Standard deviation is this much, and median, as I calculated here for 2018, is this much, and this is the variance, simply the square of standard deviation. For 2018 is this much. Wow, as you can see, the square of the standard deviation is very large. So we can simply calculate the summary statistic by using this type of function. When we need to calculate the percent difference, this can be easily done by adding a new variable by using the function mutate. This mutates the original data sheet or data frame by adding new columns. So for example, first we calculate this fraction of difference, which is the sales in 2019 minus sales 2018, use parentheses to protect it, divided by sales in 2018. So that's the relative sales change from 2018 to 2019 as a fraction. Because this fractional change is already created in this part, so we can reuse the created variable that's fractional difference and change that to percentage difference. The fractional difference to percentage difference is simply altered or transformed by this factor of 100. So we have percentage difference, but to display the percentage as percentage, we can use the text tool to change the string display strategy. Let's see the result. As you can see, I created a new column based on the existing 5 columns, actually based on only these 2 last columns of the fractional difference. For the first row, this fractional difference is 0.15. And later, I transformed it into percentage difference by multiply 100 with this fractional difference. Then I display the percentage as a text variable. As you can see, all the text variable would be left just, and all the numerical variables will be right just. So that's also an easy way we can tell the type of a variable. And just as in Excel, this is only display, it does not change the content in the values. So for this 16%, the computer understands it as a text or string value. It won't be able to sort it. Because it's not understood as numerical value. All right. Here, how can we apply some conditional formatting? Well, we won't see the formatting thing here because it's rarely used, but we can still apply the conditional function. So what if we want to create a column named color so that when the percentage difference is smaller than 0, we have red, otherwise we have green. This can be done using the if-else statement. So here, first we create a variable called the percentage difference, or actually this would equal to different fractional difference, right? So we can simply change the variable name this way. Let's see the outcome. Based on sales in 2018 and 2019, we calculate this fractional difference. If it's greater than 0, we have green. If it's smaller than 0, we have red. So if you want to know more about the if-else function, you can use this question mark to find the help function, and this can be found here. Well, last two parts. How can we show the number of models for each manufacturer? So my understanding is the we want to find the unique models. Of course, here we already have all the rows in model is unique, so this won't make a difference. But this is how we can do so. First, we start from the car data frame. Group it by manufacturer. So each manufacturer has a different role in the summary result. What we want to summarize is a new variable called model count, which is calculated as the length, or actually the number of elements in a vector in model. And to avoid repeated values in model, we can use unique. So we can have functions inside of functions. Let's see the result. So here we see that each manufacturer takes one row, and to the right, there's a new column named model count. That's the number of model, unique model observed here for each different manufacturer. So for Kia, there's 3. Sometimes the pipe operator is preferred over this parenthesis, just so that we can easily understand the step of the different functions from the first to this to the next. So this gives us the same result when we change this part from function of function to function after function. So we would see the same result as here. All right. Last step is where we can find the sum of sales in February 2019 for each manufacturer. Because it's to be grouped by manufacturer, we do this by group by function after starting with car data frame using the pipe operators. After grouping by manufacturer, we summarize by forming a new variable called sales 2018 sum, a variable calculated as the sum of sales in 2018. So we can find the result by viewing it in this editor. So each manufacturer, as before, takes a different role. And in this new column, sales 2018 sum, we have the summation of sales. All right, this is all the steps instructed here as the cumulative exercise. As you can see, up to here, there may not be substantial evidence showing that writing the script can be easier than using Excel functions. But if we move on to more complex projects, when we have thousands of rows and hundreds of columns to process, tools alternative to Excel can be handy, where we simply need to write a few lines of a script so that we don't need to manually find the different functions and different index in Excel sheet. Well, to move on, I'm going to show that R and RStudio can do much more beyond just data manipulation. In this class, in the future, we are going to learn a few different techniques with Excel to do data analysis. In our syllabus, we have it here. We are going to learn descriptive statistic, some summary tables and data visualization, and the basic statistics and the probability theory, and the sampling techniques. And we also have inferential analytics, as well as linear regression and time series analysis. These can all be done in R fairly easily. For descriptive statistic, for example, we can find the correlation coefficient between two variables using the correlation function. Here, I'm saying that the two columns I want to find the correlation is between the column that's inside the car data named sales February 2018 by designating using the $sign, and another variable would be 2019 sale. So let's see that this correlation coefficient is 0.935. This is very high. We can, of course, using this with function so that we don't have to type the car data time once and again. It gives the same result. So here, basically, we are saying that within this data frame car data, we find the columns named these things. So we no longer need to specify the column, the data frame name for each column. And R can be very helpful when we want to do automatic reporting. So here I wrote a very simple for loop. so that it looks over unique manufacturers and find the data for this manufacturer and prints an outcome, which is the sum of sales, whether it's increased or decreased. Let's see the result. So here, in no time, it looks through the, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different manufacturers. And based on the sales summary statistic, the sum of sales decreased or increased. It seems most of the sales decreased and only 2 increased. So this is how you can do a for loop. I won't go into the details, but as you can see, it conveniently gives us some automatic reporting so that you don't have to write each line yourself. Using R, we can also do hypothesis testing easily. For example, to test whether the correlation coefficient between the 2018 sale and 2019 sales is significantly different from 0. We can use this correlation test function. That's correlation test. And here, simply we find the test statistic, some df, a p-value, which we will learn in latter part of the course using Excel. A p-value usually smaller than 0.05 is designated a significant result. So here we can announce that we have evidence showing statistical difference from the correlation coefficient, which we observe as 0.93, actually 0.94, rounded, from 0. Well, some students would ask, typically in previous course, if we already observed the correlation coefficient to be 0.94, why do we have to test it, whether it's different from 0? Well, it has something to do with sampling error. What we observe in the sample can be by chance. If we if we collect another sample, the correlation coefficient can be a different value. So how can we determine whether we have confidence our correlation coefficient is not 0? That's how we can do so by using hypothesis testing, which corresponds with some p-value and some test statistic. Here is a t-test. Well, we can also do a t-test for group difference. This is group comparison of the average sales in 2018 and 2019. So here what we are testing is whether the sales in 2018 and 2019 are statistically different. So as we see that we have 2 columns here, we can find the mean value of each of them. As shown here, the mean sales in 2018 is this much, and in 2019 is this much. It's slightly decreased, but whether this slight decrease is statistically significant, that's what we need to test. And here from the outcome, we can see that the t statistic is fairly small, whereas the p-value is close to 1. It's larger than 0.05, so that we do not have significant evidence showing a statistical difference between the 2018 sales and 2019 sales mean outcome. Well, because here for each of the observation, this 2019 value is matched with 2018 value, we can find a more powerful test that's paired t-test, which essentially tests the difference between paired observations. So here, what we test is whether this difference between 2019 and 2018 is statistically different from 0. Well, the test outcome comes with these. It's a one sample t-test. The sample estimate is this much, negative 812, which shows a slight decrease from 2018 to 2019. So is this difference significant? And from here, we find that because the p-value is greater than 0.05, so at some significance level, we do not have significant evidence showing that this decrease or change in sales for matched manufacturers from 2018 to 2019 is different from 0. So we could also say that sales in 2018 and 2019 did not find a significant change. Well, you can also use R to do linear regression, which can be also done in Excel. But in R, we can simply make it in one line. For example, if we want to estimate the sales in 2019 based on sales in 2018, we simply use a linear regression, linear model. In the parentheses, we give a formula where left to the tilde symbol is the y variable, the outcome. Right to this tilde is the x variable, the explanatory variable. Then we designate the data source as the hard data frame. Then Control Enter. It gives us the coefficient estimates. So we can assign this linear model outcome into an object named the OLS model, because this linear regression is typically estimated using a method called ordinary least squares. So that's why we usually call it an OLS estimate. So out of this model object, we can extract the coefficient, right? The intercept and the coefficient, as well as the coefficient can be also done this way, same result. We can also extract the residues, which is the observed value minus the estimated value. And we can also extract the fitted value. We can also find some more details of the model using the summary function of the model object. Here, in addition to the coefficient estimates, we can also find its standard error and t-value and p-value, along with the model summary statistic, which we will learn in the latter part of the course about degree of freedoms and residue standard error, and also R-square. Two types, there's R-square and there's also adjusted R-square. Here it's above 0.8, and we also have F statistic. You will also find these reported in linear regression models when doing it in Excel. You can also view the model to find more components in the model. including residues and coefficients, as well as other components. For example, if we see the components part of the summary model object, then we find this table, which includes not only the coefficient estimate, but also the standard error, t-value, and p-value, which is this part in the summary output. And we can also find the sigma, which is this much. That's the residue standard error. That's the average distance from the estimated y value to the observed y value. So what we estimate and actually measured the 2019 sales can be assessed by the difference between them. So that's what residue standard error represents, the average distance. And we can also extract the R-squared and adjusted R-squared, which is very similar to these numbers, which is, but just not rounded. And we can also test whether some single coefficient is significantly different from a constant. Here I'm testing whether the coefficient of the sales 2018 is statistically different from 0. And because the p-value is smaller than 0.05, so at the significance level of 0.05, we will learn the detail of such hypothesis testing in the latter part of the course in Excel. Because of this, we would conclude that there's statistical difference from our coefficient estimated here, which is 0.82. Is statistically different from 1. Of course, we can also test whether it's statistically different from 0. As you can see, the p-value is even smaller, so we may have a stronger evidence to claim such difference. Well, what I love most about R is the plotting function, because otherwise in Excel, I would have to find the regions of cell values to plot and maneuver over the plotting function, plotting window, which to use as the axis, y-axis, and which to use as x-axis, then adjust the appearance, then adjust the size. For doing one plot is okay, but if I do hundreds of plots, which actually happen, then it's not very scalable. But in R, this procedure can be automated by repeating the same functions. So we just load a package called ggplot2 for plotting. Then for plotting, we simply need to form the data into a long format. The long format basically means that for each observation, we can actually see that for each observation. All right, that's fine. There's only one x variable and one y variable. So here, I'm going to use year as x and sales as y. So let's just see a basic box plot. It looks like this. Nothing fancy, but it tells us the some summary statistic about sales in 2018 and sales in 2019. Here, a box plot, which we will learn in upcoming classes in Excel, the box plot will show the median value using this middle horizontal line, and the first quartile or the 25th percentile using the bottom border of the box, and the third quartile or 75th percentile using the upper, the top of the box. Then these two longer lines is basically 1.5 of this distance, and these dots are the actual observations of different sales in 2018 and 2019. So we can also generate density plot similarly. A density plot is very similar to a histogram, as we can see here. Density plot, when there's more sales in this area, in this range of sales, then the Y value goes higher. We will learn more about what density means in the variable and the distribution section of the course, and illustrate the results in Excel. We can also make some histograms. Here I overlap the histogram of sales in 18 and 19. Red for 18, blue for, or green for 19. And it shows how many different models are manufactured in this range of sales. And last part is a basic scatter plot. So we can make a scatter plot of the relationship between 2018 sales and 2019 sales. We can make these plots more beautiful by supplying more specifications of the plotting function. So here, I just generated what I used in the cover photo of this session. So as you can see, this is still a box plot, but I have connecting lines between the matched observations. So we know that for some model, whether the sales increased or decreased from 2018 and 2019. And I also applied some formatting functions so that the sales is shown in thousands, and the year is just as year instead of sales in the year. So it's quite apparent and very simple and aesthetically appealing. Then after creating these plots, we can save that. A typical format is the raster image, PNG. So we can do so like this. And I specify the width and height that's recommended as the number of pixels for Facebook events. And so that's how I generated the exact outcome as here. And because in the beginning, we designated the working directory as the download folder, so that this generated plot is also here, the same folder as we find the original Excel file. So that's the image I generated. This is a raster image. What I prefer is a vector file, which will stay sharp wherever you import it. So here, I use SVG file format for a vector image. As you can see here, that's the vector file. So if you zoom in, no matter how large it goes, the outcome is still very sharp. Instead, going back to this raster image, if you zoom in, as you can see, some part of the text and image elements is already blurred. So if you need a high quality printing file, go with vector, and it also saves file space in most cases. And we can also make a beautiful scatter plot. I wrote many lines, so I won't go through all of them, but just to show you, just to show you the outcome. Please a line somewhere here. Well, I'm going to remove this part. All right, as you can see, this is a typical, actually a more a scatter plot with richer outcome. We can create similar plot in Excel, but if you need to repeatedly create similar files in the future, then R could save the time. Once we save it into a vector file, we find that great. In here, in the download folder, I have this one. I specifically make sure that this y-axis and x-axis is 1-to-1 ratio. And I added this diagonal line to show the no change line, because if we have sales of 2018 equal to 2019, that's what this diagonal line shows. That means sales in 2018 equals sales in 2019. There's no change. But for points that's below this line, that means the 2018 sale is greater than the corresponding 2019 sale. So it's decreased. But if it's above this line, that means the sales in 2019 is greater than the sale in 2018. So that means the sale increased. And I applied the conditional formatting for the color of the points so that those decreasing models would be colored red and those increased would be colored green. And I also added this trend line, which is the regression line that I illustrated earlier using a linear regression model with the OLS estimating method. And the gray ribbon is the confidence interval for the regression line. We will learn more about confidence interval in the hypothesis testing section of this course. All right, this summarizes all my demonstration in R. I hope this gives you a perspective of a different tool that can do equivalent jobs with Excel and also extend the analysis to richer outcomes and results. But for this course, R is totally out of scope, so no worries. You don't have to learn everything right now, but R might be a further step you want to take after this course. In the rest of the course, we are going to learn most of the content using Excel file. So make sure you review the content that I demonstrate today, of the basic formatting and mathematical operations in Excel. That concludes my demonstration session. I'm going to save mine. data files.